All right. So, hello 30-2s. So we're still doing rational expressions. This is from your notes package. But today we are doing adding and subtracting rational expressions. So that starts on page 35. So let's just hop and see where we get to. Okay, almost there. Alrighty. And that's the assignment just finished. So remember, you can also go back, fill in those pages with study notes. But we're looking at topic 3, adding and subtracting rational expressions. So what we're going to do is we are going to review our rules for adding and subtracting rational numbers, and we're going to use those rules to help us add and subtract rational expressions. So when we're adding and subtracting rational numbers, the first thing we have to do is we have to get common denominators. And the reason for that is because the denominator in a fraction in a rational number tells you what are the size of the pieces. So we have to make sure that we're talking about pieces that are of the same size. So when we're adding 1/2 and 2/3, a half is a very different size than a third. So we can't just add it straight across like we do with multiplying and dividing. So first thing we need to do is find a common denominator. So what we look for is we look for the numbers, a number that both 2 and 3 are going to go into. We're going to look for the lowest common denominator. Now with 2 and 3, they're both prime, so the easiest way to find that is to multiply them. So if we're adding 1/2 plus 2/3, now if I multiply 2 and 3, I get 6. So that's going to be my lowest common denominator. Now, whatever I multiplied the 2 by, in order to keep that fraction the same, I also have to multiply the 1 by. So I multiplied this by 3. So that means I have to multiply the 1 by 3. So 1 times 3 is 3. With the second one, 2/3, I multiplied the 3 by 2. So I have to multiply the 2 by 2. So I get 4. So now I have fractions that are the same size pieces because they have a same denominator, and now I can add them. So I keep that denominator. I always say you work so hard to find it, you might as well keep it. And then I add my numerators. So 3 plus 4 is 7. Now, normally when we're adding rational numbers, this is an improper fraction and we would change it to a mixed number. But we're not going to worry about that for now because we don't do that with rational expressions. So we're just going to leave it as an improper fraction. So what we do for adding these rational numbers is we find common denominators. We change the rational numbers to equivalent fractions. And then we add the numerators, keeping the new denominator. Okay, so that's basically what our steps are, and those are going to be outlined later on in the note package. Probably written neater, typed, so you can read them easier. Now, if we're going to subtract the same two rational numbers, how would the strategy change? Well, the only thing that would change, so if we look at these, we've got 1/2 and 2/3, so I have 1/2 minus 2/3. I'm still going to find the same common denominator, which is 6. I'm still going to convert to equivalent fractions, so the 1/2, I times it by 3, so I would get 3/6 here. the 3, I times it by 2, so I would times the 2 by 2 and get 4 there. And then I would subtract. I subtract the numerator, so it'd be negative 1 over 6. So the strategy would change. I just subtract the numerators. Otherwise, it's the same process. Okay, and occasionally you're going to get negative numbers. You could get negative numbers with you adding if you're adding negative rationals. Now we use this strategy when we're adding and subtracting rational expressions. So let's look. I have negative 2x cubed over 3, and I want to add 5 over 6x squared. So adding those, I'm actually going to write it over here so that I have a little more room because I'm also going to do the subtraction question. So I have negative 2x cubed over 3 plus 5 over 6x squared. And I need to find a common denominator. Well, here's the neat thing. 3 is a factor of 6x squared. So that means that it goes into 6x squared. So 6x squared will be our common denominator. And the nice thing about that is it means we don't have to change one of our fractions. The second one stays the same because all I've done is kept the same denominator. And then I just basically ask myself, what did I multiply 3 by to get 6x squared? Well, to get the 6, I multiplied it by 2. And to get the x squared, I multiplied it by x squared. So that's what I have to multiply the negative 2x to the 3 by. So I multiply that. Negative 2 times 2 is negative 4. X to the 3 times x to the 2 is x to the 5. And that's my answer. Now when I'm adding these, I keep that denominator that I worked so hard for, and I just add my numerators. So I have negative 4x to the 5 plus 5. Now, when you get your numerator, you might look at it and say, can I factor it? In this case, you can't, because if you could, you would want to simplify it further. But in this case, you can't, so you leave it as it is. Now, what will we do if we're subtracting? Well, it's those same fractions, but with a subtraction. So it would be negative 4x to the 5 over 6x squared. And instead of plus, it would be minus 5 6x squared. So we would get negative 4x to the 5th minus 5 all over 6x squared. Okay, we still converted to the same fractions. And we're just basically now adding or subtracting as we can. Now, how are they different from rational numbers? Well, you've got variables. That's the big factor. You might be able to factor your answer. We don't know yet. Okay. How are they the same? You still find a common denominator. Oh, what am I writing? Denominator. And then you have to have equivalent expressions. All right. We're going to use those same rules that we learned for simplifying. We use the rules we use for simplifying rational expression or polynomials. Okay, and those rules should guide us. Okay. How can you determine the non-permissible values of the variable in the sum or difference? Oh, I forgot that when we did that. I've got my answer there, and I didn't find my non-permissible values. Well, I can take a look. We take a look at our denominators. So our NPV for this one is 0. Same thing there. You check out the denominator, all denominators, to find your non-permissible values. Okay, alrighty. So let's look. Here we have some summation. I told you it'd be written out neater than what I talked about. So these are the strategies we use. We find the lowest common denominator for all the rational expressions. We find equivalent expressions for all of the rational expressions so that everything has the same denominator. So common denominator, same denominator in the equivalent expressions. And then we add or subtract the numerators, keeping the denominator the same. And then we have to state our restrictions. Any polynomial that ever appears in the denominator is used to determine the NPVs. So sometimes you're going to have that, because that denominator is going to be changed when you add and subtract, when you find your common denominator, that's going to impact your non-permissible values. So let's do a bunch of examples, because that's the best way to learn, is by practice. And we're going to find the lowest common denominator and the NPVs for each question, and then simplify. Now here, x over 2 plus 2x over 3, the lowest common denominator is 6, and the NPV, there is none, because there's no variable in the denominator. So we want to write this over 6, so we have to say, what did we multiply by? So here I multiplied this 2 by 3, so I multiply the x by 3, so I get 3x. Here I multiplied the 3 by 2, so I multiply 2x by 2, so I get 4x. And now I can add. I have 3x plus 4x, so I get 7x. Okay, and there are no restrictions, so that is my answer. Okay. Here, I've got my lowest common denominator is going to be, well, look at our new numbers. I have a 3 and a 5, so it'll be 15, and then I have to account for that x, so 15x. Based on that, looking at my possible denominators, my non-permissible value is 0, because x can't be 0. So let's find our equivalent fractions, and then think about what did we multiply each thing by. So 15x, I multiplied the 3 by 5x. Sorry, I'm just going to rewrite this with a dot because it'll make it clearer, I think. So 5x times 3, so that means I have to times 2 by 5x. And when I do that, I get 10x squared. Okay. And then here, I multiplied the 5x by 3 to get 15x. So I multiply the 4 by 3. So I get 12. Now, when I have my solution, I keep the denominator. I have 10x squared minus 12. Now that top, I can simplify it further because I can factor out a 2 from both of those. So it'll be 2 5x squared minus 6 over 15x, and x is not equal to 0. That's my NPV. Okay? Right on. Let's look at another one. Now these are just monomials. It's going to get more complicated because we are going to have binomials in there, and we have to think about what we're doing there. So here I have 3b and 5b. So my lowest common denominator is going to be, well, what I do is I multiply those, both of those numbers are prime, so I multiply them. 3 times 5 is 15. But they both have a b, so I can just leave it as a b. I don't need to put b squared because I want my lowest common denominator. For my NPV, b cannot equal 0. Okay, so now let's do our conversion. So 15b minus 15b. Worked hard to find that lowest common denominator. I might as well keep it. So I multiplied this by 5 and this by 3. So that's what I multiply the top and the bottom by. And when I do that, I get 5 times 2 is 10, 4 times 2 is 12, and now I can do my subtraction. So it's all over 15b. 10 minus 12 is negative 2 over 15b, and b is not equal to 0. Now you'll note that I have to make sure I'm talking about the right variable. So be careful. We use x a lot, but every once in a while we have a different variable. So you need to make sure you use the correct one. Let's look over here for D, my lowest common denominator. Well, 4 goes into 8, so 8 will work. X goes into x squared, so x squared will work. So the first fraction isn't going to change. Now looking at this for an NPVs, x cannot equal 0. So 8x squared plus 8x squared. So for the first one, I didn't actually have to change anything, so I didn't change this at all. But the second one, I multiplied by 2x. So I have to multiply the top by 2x. So 1 times 2x is 2x. And now I can add these together. So I'll have 3 plus 2x over 8x squared. And remember, x is not equal to 0. So that's my solution. Okay. Now, remember always to state the non-permissible values as restrictions with the simplified form of a rational expression. So you take a look at that and you say, can I simplify it further? And we can't. That's in the lowest terms. Okay. So let's move on up. Now, when we get into binomial denominators, it gets a little more complicated. I'm going to take a drink of water because I've been talking a lot today. So when we have binomial denominators, the easiest thing to do, if they're not the same, the easiest thing to do for our lowest common denominator is multiply them. So my lowest common denominator of these is going to be x times x minus 4. Now I'm going to leave it in factored form because that will make my answer easier. And then I can figure out my NPVs. For my NPVs, x cannot equal 0 and it can't equal 4. So now I've done a big chunk of my work. Now, looking at this, my lowest common denominator is x times x minus 4 plus x times x minus 4. And then we just need to figure out what we multiplied it for. Well, here I multiplied this by x minus 4. So I'm going to multiply the top by x minus 4. And I would get 3 times x minus 4. Here, I multiplied this by x, so I'll multiply this by x. So I will get 2x. Now, in this case, we're going to write our new denominator that we worked so hard to get. And we have 3 times x minus 4 plus 2x. In this situation, you're not done. You're going to expand this and see if you can simplify it. So we would get 3x minus 4 plus 2x all over x times x minus 4. Now we're still not done because I've got some like terms. I've got a 3x and 2x. So I've got 5x minus 4 all over x times x minus 4. Now I say, can I simplify the numerator at all? No, there's no common factors. So I just, now all I have to do is list my non-permissible values. 0, and 4, and this would be my final answer. So this is the kind of math where you look and you're always saying to yourself, I'm not sure if I'm done. So you have to learn to trust yourself and ask yourself those questions. Can I factor it anymore? Can I reduce it anymore? If you can't, then you're done. Okay? Think about those questions. Can I common factor? Is it a difference of squares? Okay? Let's take a look at this next one. Well, the nice thing about this one is that the lowest common denominator is the x minus 2 because that's what they both have. So we don't even have to change our denominator. And our non-permissible value, well, x can't equal 2. Okay? Now, because those are like that, I can just simply do my subtraction. However, because it's a subtraction, think about your simplifying rules. I need to distribute that negative sign to both of those. So when I write this out, it's all over x minus 2. I have 2x plus 1 minus x plus 4. And all I did was multiply everything in the brackets by that negative 1, that minus sign. Now I'm going to simplify it. So I have 2x minus x, which is x, and 1 plus 4, which is 5, all over x minus 2. And my non-permissible values, x can't equal 2. So this would be my final answer. Fun, hey? So really take your time, do your steps, remember your rules for simplifying. This next one, our lowest common denominator, they're different denominators and they're binomials, is going to be n minus 3 times n plus 2. A lot of times with these, to get your lowest common denominator, it's just a matter of multiplying the two denominators. And my NPVs, well, n can't equal 3 and it can't equal negative 2. When we write that in the answer, we'll put it in the right order. So here, I'm going to have n minus 3 times n plus 2 minus n minus 3 times n plus 2. And then what did you do with each of them? Well, here I timesed it by n plus 2, so that's what we're going to do to the 6. So it will be 6 times n plus 2. And here I multiplied it by n minus 3. So that's what I'm going to do to the 4. So it'll be 4 times n minus 3. Now, it's a subtraction, so we need to treat this like that's a negative 4 when we distribute it to beat each of these. So let's do our expanding. So the new denominator is n minus 3, n plus 2. The first bracket I'm going to distribute here. It's going to give me 6n plus 12. And the second bracket, I have negative 4 times n, so it'll be minus 4n. And then negative 4 times negative 3, so it'll be plus 12. And now I have some like terms I can collect. 6n minus 4n is 2n. And 12 plus 12 is 24. All over n minus 3, n plus 2. Now I'm not done because I can look at that top and I can say to myself, oh, I can take a 2 out of both of these. So it'll be 2n plus 12 all over n minus 3, n plus 2. And then I remember my non-permissible values. Well, I made my list. So n is not equal to negative 2 and it's not equal to 3. You keep going till you're completely factored. Okay? All right. Now, sometimes they're going to get more complicated. So we can use our factoring strategies. We did all that. We did a little bit of factoring review to simplify our rational expressions. So looking at this, I'm going to rewrite them. But looking at my denominator there, This can be factored. It's a difference of squares because x squared is a perfect square and 16 is a perfect square. So this can be factored to x minus 4 times x plus 4. So that means that all I have to do to the second fraction to give it the same denominator is multiply the top and the bottom by x minus 4. And then I will have my same denominator. Helps sometimes to write the brackets around. The first one remains the same because it has it doesn't change. The denominator actually is only being factored, it's not being changed. So always take a look and see, can I factor that denominator? Because by factoring it, it might make things simpler. Now I can do some adding. X minus 4 times x plus 4. And remember, it doesn't matter what order they are in. They're in a different order here than here, as long as the factors are the same. It doesn't matter if you have 2 times 3 or 3 times 2. They both will give you 6, right? And I have 32 plus, and if I distribute this 4, I'm going to get 4 times x, which is 4x, and then 4 times minus 4, which is minus 16. So when I simplify that, so I have my x minus 4, x plus 4, and I'm going to get 4x, I'll write the x's first, and 32 minus 16 is plus 16. Now, I'm not done. What goes into both 4x and 16? Well, 4 does. So I can factor out a 4, and I'll get x plus 4. Ooh! And then I get x minus 4, x plus 4. And look what happens. X plus 4 and x plus 4 will cancel out because they're factors on the top and the bottom. So I'm left with 4 over x minus 4. Now I didn't figure out my non-permissible values, but let's go take a look up here. This is going to be, because that encompasses this and this, that's going to tell us our non-permissible values. So x cannot equal minus 4 or 4. There's just the two of them. Okay. You want to make sure that you're not forgetting to put your restrictions in. But it's kind of neat how factoring the denominator can actually make that simpler. Okay, and it's less work overall, because what you wouldn't want to be doing is multiplying x squared minus 16 times x plus 4, because you're just going to get a big old mess. Okay, so factor first. So here we have a bunch of other examples where we're going to factor first. Sorry, I just took another drink of water there. If I look at these, that first one there is 2x over x minus 1, x plus 1, subtract 4 over x minus 1. So again, like that last question, if I want the same denominator, all I have to do is multiply this one by x plus 1. And then I'm going to have the same denominator for each fraction. So use factoring to make your work easier. Okay, now to combine them, I have 2x minus 4 times x plus, excuse me, x plus 1. Goodness. And it's all over x minus 1 times x plus 1. Now I'm going to expand this, remembering it's a minus 4. So I will have on the bottom x minus 1 times x plus 1. On the top, 2x minus 4x minus 4. And then to simplify that, and I'm going to just shorten this so that I could fit it in the page. So I now have 2x minus 4x, so that's negative 2x minus 4 all over x minus 1 times x plus 1. And I can factor this. I can take I'm sorry about that. I'm sure that's really distracting to people when that happens. All the way back to multiplying. My goodness. There we are. So I can factor out a minus 2 and get x plus 2 all over x minus 1, x plus 1. And our non-permissible values, x cannot equal -1 or +1. So it's not as nice as the last one, but it certainly looks a lot more neat and tidy than you think it might be. Okay, so factoring is a good idea. Make your life a little simpler. Okay, and you never know when it's going to, how it's going to impact your answer. Now here, we're going to factor both our denominators. I have 3a minus, I'm going to factor the top there in a second. So here I have 4a plus 2, so that would be 2 times 2a plus 1. I just factored out a 2 from both of those, from both of these terms. On the top here, I'm going to factor out a 3, so I get a squared minus 2. So close to being a perfect square, but it's not. You know what? I'm actually going to leave it, because when we subtract, it's not going to make a difference. Sorry. 3a squared minus 6. Forgot about that. Factor the numerators in the last step, not the first step. Factor the denominators in the first step, okay, not the last. Now this second one here, 4a squared minus 1, is a difference of squares. It's 2a plus 1 times 2a minus 1. Sorry, this got squinchy. 2a minus 1. So we can see we have some similar factors. We have this similar factor and that similar factor, but we have some different factors. So we need to account for all of them. So basically what I'm going to do is I'm going to multiply the fraction by the opposite missing factor. So what that does is it becomes 2 times 2a plus 1, and then what I'm going to multiply this one by is 2a minus 1, okay? And this will be, I'm going to multiply it by the 2, and then I'll get my 2a plus 1, 2a minus 1. Sorry, it's so tiny. So what that means is I have my 3a times the 2a minus 1, and I have my 3a squared minus 6 times the 2. Okay, so you can see I've done the same, I've converted their equivalent fraction because I'm doing the same thing to both. Okay, now what does that look like? So here, what that means is that on my denominator, I have 2 times 2a plus 1 times 2a minus 1. The first numerator I have is 3. I'm going to distribute it. Okay. So I have 3a times 2a, which is 6a squared. 3a times minus 1 is minus 3a. Then I have -2 times 3a squared minus 6. So minus 2 times minus 2 times 3a squared is 6a squared, minus 6a squared, sorry. And then plus, because it's -2 times -6, so plus 12. Ooh. Now let's do some simplifying. We can do that easily enough. We keep our beautiful denominator, 2a plus 1. A minus 1, and you can see this is the last question before the do you know, so it should feel like the hardest one. Okay, there's a lot more to do in this one. Now let's see what we have. We have a 6a squared minus a 6a squared, so they are going to subtract out, and what I'm left with is -3a plus 12. Now I can still factor that I can take out a negative 3, and I'm going to get an a minus 4 all over 2 times 2a plus 1 times 2a minus 1. I'm sorry, it's not prettier. And then our non-permissible values, a cannot equal negative 1/2, and it can't equal positive 1/2, because that's the only variable on the bottom. Okay, again, that C is probably the more challenging one because you have to do more work because you can factor both denominators, so you really have to account for them. But it really is using the same rules that we use with fractions. So what are our need to knows? Strategies used to add and subtract rational numbers are used to add and subtract rational expressions. So when we add and subtract rational expressions, you have to have a common denominator. What are our steps? Factor the numerators if possible. Factor the denominators if possible. Identify the values of the variable that at any time make the denominator equal to 0. This is for our NPVs. Determine the lowest common denominator. Rewrite each rational expression as an equivalent expression with the lowest common denominator as the denominator. Add and subtract the numerators and rewrite the denominator. Collect your like terms, then factor the numerator if possible. I would actually say question number 1 or part 1 is you don't do that very often. Okay, unless you can reduce your fraction and make it simpler, that's the only time you would actually factor the numerator. After you get your answer, simplifies using your common factors, and then remember to state your restrictions, your NPVs. Okay, now the lowest common denominator is the product of all the common factors and all the unique factors of the denominators. It's not always the product of all the denominators. So you really need to, that's why factoring that denominator really can help you. Now the best way to learn math is by practicing. So we've got a couple pages of practice. So 39, 40, 41, 42, 43, and then the key is there. There's also one on the top of 44. And it may seem like a lot of pages, but that's also because they've given you space to work. But that is adding and subtracting rational expressions.